Hey, Elliot from Spaghetti Lab, and in the last video I showed you how to upload code to the Arduino. So in this video I'm actually going to show you how to wire up a basic circuit. In this case it makes an LED blink, which you can see is happening right over here. And I'll just show you what this kind of arrangement looks like. I'll talk about what the parts are to do this. But first I'm going to actually talk to you a little bit about safety. I just unplugged that for a moment so I don't distract you. And what I think is important to review right now is that it's okay to touch the live electronics in this scenario. It's actually a low amount of voltage that's running through the circuit, and that's actually 5 volts to be specific. Now the power originally is originating from the USB cord, which comes from the computer, but the Arduino will take care of not sending out a high amount of voltage. Okay, now it's possible to work on circuit boards from other machines and gadgets and that sort of thing. But you have to remember that if the thing was plugged into the wall, it is very dangerous, and it can be, say, hundreds of volts of electricity, and it is definitely enough to electrocute someone. So that's just a quick disclaimer. In this case, it is safe because you're going to see I touch wires while the circuit is running. Okay, so now let's talk a little bit about the parts involved in this video. So the first one is the Arduino, which is plugged in, and you can see it's blinking from the last video, and we uploaded the blink code to it. And the next part is just a basic LED. I picked Rudolph Red, and here is the breadboard, which is a classic kind of engineering student's tool for, I think, since around the 1980s. And it allows you to prototype a circuit in real time because there's metal connections at the bottom of it which help to connect things. So breadboard is very cool, even though they look kind of geeky often. There's all kinds of colors you can get them in and different stuff, and I can show those in another video. Now this small object here is a resistor, and resistors basically slow down electricity and they help even out the circuit. So don't get too intimidated by the phrase and the terminology. There's a whole world of resistors. They come in probably hundreds of measurements, and actually there's little bands on a resistor which help you figure out what the resistor is worth. But typically when you're starting out, when you have a kit or something, there's oftentimes just a few different resistors in the kit, and they will tell you what the resistor values are. And finally, I have just 2 hookup wires in this case, and both ends are the same. Doesn't matter what color they are. So if the diagram shows a red and black wires, don't worry if your kit has orange and green wires. That doesn't matter. It's only really for your reference. Okay, so that's what we're using to make this circuit. I'm now going to show you a diagram of what's going to be happening. Okay, so we are now in a program called Fritzing, which is used to make these kinds of diagrams, and it can even help manufacture an entire device with a schematic. So we're going to use this program to get a handle on what's going to be happening before I show you the actual wiring. So just trying to find the right zoom level. So here is the LED light, and I'm going to try to zoom in. Now the LED, the side with the bend in it is the longer side, and the other one is, even if you highlight over, it's showing us anode, which is positive, and then cathode. And the cathode is the shorter end, and it will actually go to negative. And don't worry if you don't know what I'm talking about with positive and negative. I find it's better to just jump in and then learn some of the specifics later. So I'm bending the leg a bit because when we actually get on the breadboard, it's not gonna be easy to put them right next to each other. And the first easy connection is I can take that smaller leg and I can run it to the ground port on the Arduino. And let's show you that. So smaller leg went to ground, and the bigger leg is going to eventually go to pin 13, except we're going to be putting a resistor in there to help smooth the circuit. And so I plop my resistor down. The resistor doesn't matter which way it goes. And then I'm going to take the other wire and hook it to 13, and this other wire will be, that one's, let's just say, okay, I'm going to say this one will be what I have here. I have white and black. Black is often used to denote ground. So what's going to be happening here is we will complete a circuit from positive, which is 13. It's going to be pulsing out the electricity, and everything's going to go through the LED light and make its way back to ground. So let's wire that up actually in real life now. Okay, so we're now at the breadboard, and I apologize in advance if something is hard to read or blurry, but I'll do my best to point out everything that's necessary. So on the breadboard there is numbers and letters, kind of like the game Battleship. I would say do not worry about them almost ever. They would only be important if a tutorial was being specific about what number goes where. Now in our diagram we said that the shortest end, which is the one that's not have the one that doesn't have the bend in it, is going to go to ground. So I'm going to plop this on the breadboard, and it sometimes needs a bit of pushing, especially on a newer breadboard. And so it's now on the breadboard. What I want to point out though is they cannot be sitting, the LED light cannot be sitting on the same row, because if it was on the same, let's see if I can show that, it's tricky. If it was on the same row, there wouldn't be, it wouldn't be able to create the circuit. So I'm just going to plop it down. And we said the black one will go to ground, and I have my resistor. Now the resistor legs are very long, and you can cut them down once you get more comfortable. So there's a bit of so the resistor does a jumps a few spaces because the legs are long, and now the resistor is on, and finally I will take where the resistor ended up and plug that into pin 13. So I am ready to plug in the USB ports now. So it's actually not working, which is a good thing to show you because this is part of the process. So these two pins were one over from where they should have been, and there we go. So now it's blinking, and I also got to show you a bit of troubleshooting. Let's see, it's quite bright. And the resistor, if I actually had a higher resistor level, this light would dim. Let me see if I can show that to you. So I can take out the resistor, and I have another one handy that's of a higher level. So it's going to block more electricity from entering the circuit. And I think you should be able to now see that it's not blinking as crazy as before. So, and as you can see, I'm also touching the circuitry, and it's not a problem. So something that wasn't discussed in this video so far is the connection between the orange LED that's blinking on the board and the pin 13, which wired up this circuit. And I'm just going to explain how that works and how you can get this to blink on other ports. So what this is called is a digital output. The Arduino also has analog input, which is what you would use for something like a knob, and it also has digital input, which is what you'd use for something like a button. And the Arduino has 13 digital ports on the side that we've been working with. And in the standard Uno layout, the internal LED is the same as pin 13. And we're going to go back into the editor, and I'm going to show you how you can change that from the default blink code to go on another port. So we're in the Arduino IDE, the editor, which allows us to update the program running on the device. And we're in the blink sketch, which I actually didn't show you in the last video, that the blink sketch is found. There's all these example sketches here, and they're really useful because they pretty much have almost everything you need right inside this program, which is free software. And so the blink was found here. Now inside of blink, what happens is when we set up the program, who is the Scott Fitzgerald and Arturo Guadalupe, the people who wrote this program, they declare the pin that's going to blink as something called LED built in. Now LED built in is a function that just refers to that pin that's on the board and that it's mapped to 13, and that was kind of, I would say, that's kind of the fact that it's mapped to 13 is sort of extra knowledge that you would just have to read about. And actually it mentions it at the top of this text, and it also says here on the MKR 1000 this is pin 6, because I would say that the MKR board probably doesn't have 13 digital pins on it. It's probably a smaller board. So if I want to change this to say port 12, I would just write 12 here. And now I'm going to have to change that down here too, because it's expecting some consistency in the code. And I'm going to change those to 12. Now I'm going to upload this code compiling. Now the board stopped blinking because 13 was the internal, and I'm going to move over my port and the LED is blinking again. So I moved over that one cable over to pin 12 and it's working now. Okay, so that wraps up this tutorial. Now the blink overall sounds kind of, small or beginner or something, but I think it's a really important tutorial overall, because if you can get it to blink and you can also follow the steps I did after with changing the different pin, you pretty much have almost all the information you need for following along with all kinds of other Arduino tutorials of this type. So don't get discouraged if you think that making a little LED blink seems a little trivial. I think it's really good information to really nail down the basics with. Okay, so we'll see you in the next video.